Okay, let's give you guys some more practice. So here, find dy by dx of this. Okay, so yeah, so press pause and have a go. Okay, so to do this here, you've got to identify that you need to use this. Okay, so to do this here, dy by dx. Well, if you look at this here, to differentiate the inverse sign of this bubble here, then you've got to use this. So whatever this bubble is here, so don't forget this is our bubble here. Hang on. So this is our bubble here. So you can imagine this as being like this. Okay, don't forget you've got to square the x later on. So just to differentiate this here, it will become this. Okay, so when you differentiate this, it will become this, and because the bubble is a function of x here, well, when you differentiate this here, it will give you this. But then because the bubble here is a function of x, you've got to use a chain rule within a chain rule, and then later on you've got to use another chain rule. So hang on, let's start again. So here you differentiate this, it will give you this. Okay, but then you've got to come this bit here. You've got to visualize it like this. 2x. In your mind, visualize it like this, to the power of a half. So now differentiate this. So that will then give you a half here. And then the bubble itself stays intact. The bubble itself stays intact. And then this power here gets minus by 1. So it gets minus by 1. And then you've got to use a chain rule within a chain rule here. So now differentiate the bubble itself here, which will just leave you the 2 because of this. Yeah, that will leave you this 2 here. Okay, so differentiate this here, it will then give you this. Now it's just a matter of tidying up. So visualize, hang on. So visualize as this. You've got one fraction here. Remember that the power is more important than the multiplication. So when you come to visualize this, you got to do this bit first, and then you times by a half. Okay, so when you come to visualize this, you've got one fraction here times another fraction here. Well, in your mind, you've got to visualize this fraction first, because powers are more important than multiplication here. So you've got to visualize it as one fraction here, and then this here is this fraction here, and then the half, you multiply by a half, which is multiplying by this half here, and then you multiply by the 2, which is this 2 here. So you can see that here it gets multiplied to the top, and then top times top here, and then later on this will cancel out with this. So that will then give you this. Okay, and then you can tidy up this bit here, because yeah, tidy up that bit, and it will then give you this. So your dy by dx equals one fraction multiplying with another fraction here. So top times top, bottom times bottom, that would give you this. Okay, so your final answer would be this. So now jump to your graph plotter and plot the graph. Originally, plot this. This was our original function here. Okay, and then we had to differentiate it. When you differentiate it, it gives you this. It's what we worked out earlier. This is our final answer here. And get a graph plotter and plot this. Okay, you might have to, in your graph plotter, you might have to give it so you might have to call it y equals blah blah. Draw another line or whatever. Do just somehow different graph plotters will work in different ways, but somehow plot this line and somehow plot this line here, and then it will give you something looking like this. And then have a quick glance. Okay, right around here it will be a positive gradient. Hang on, it will be a positive gradient, and it's really steep. And then now looking at the blue line, around here, hang on, around here is a positive gradient. Around here it will be a positive gradient, because look, it's at this level here, positive gradient. And then around here, and again it's a really steep positive gradient because it's going uphill. Now look at the blue line, it is at a high level. So here, and the lowest level, the lowest level, the gradient would be around here, and this gradient somewhere in between here, you will have a gradient of 2. Okay, so it's not a gradient of 0. Looking at this here, it's not, well, it's not a gradient of 0. It's a gradient of 2. Just bear that in mind. Here, I know the graph seems a bit weird, but it does. This graph does make sense. Okay, and yeah. So have a quick glance. Here is a really big positive gradient, and you can see big positive gradient. Here, big positive gradient, and then up here, big positive gradient. Here, you still got a gradient here, a positive gradient here. Um, uh, yeah, you still got a positive gradient here. Looking at the blue line, you still got a positive gradient here. Okay, and the reason why this line here, the reason why the red line here starts minus a half here, the reason why it's being restricted within minus minus 1.5. Hang on. The reason why it's being restricted within minus 1.5 and a minus 1 here, the reason for that is because of this. Look, if you look at the blue line here, it's being restricted to minus 1.5 and minus 1. And the reason for that is because if you look at our original question here, remember we are using inverse sine, so we've got to use this one here. When you differentiate this, it will give you this, but this thing here will only work within the region of minus 1 and 1. So our bubble here it will only work if our bubble is stuck within minus 1 and 1. So when you come to visualize it, you got to bear in mind that our bubble here will only work within the region of minus 1 and 1. Our bubble will only work within that region. Well, our bubble is this. Our bubble is this square root thing. So we've got to put this into here. So that this is our bubble here. So this thing will only work if our bubble is within minus 1 and 1. But then let's translate that to x. Hang on. So now, well, when you square root something, it won't enter the negative realm. So let's say the lowest point will be 2. Will be 0, because when you square root something, it will never enter the negative realm. So just the lowest that will be, it will be 0. Okay, and then now take away 3 from each side here. So this take away 3 will give you minus 3, and this take away 3 will give you minus 2. Now divide every side by 2, so that will give you this, and this side divided by 2 will give you minus 1. You see, this is the reason why our Rx is stuck within minus 1.5 and 1. So looking at this graph here, this is why our graph is stuck within minus 1.5 and minus 1. Okay, and when we got to this stage here, when we got to this stage here, you can see that, well, looking at this here, this thing here will break down for many. There are many x's where this thing breaks down. Remember, if this bubble here is ever a negative number, then this whole thing breaks down. If this bubble here if this bubble here is a negative number, then this whole thing here breaks down. You see, looking at this here, there are many values of x where this whole thing here will break down, but there exists some values of x where this whole thing here will not break down, and those values are between minus 1.5 and minus 1. You see, everything else, that this function here will, well, this thing here will break down, right? But there are certain values of x where this whole thing here will not break down, and if you choose the values of x between here and here, this thing here will not break down. Okay, this thing here will not break down. So anyway, overall, our answer dy by dx equals this thing here. Okay.